Hello all. In this video we are going to discuss the course Numerical Methods and Statistics, under which we are going to discuss few topics relating to iterative methods. So we are going to see the introduction about the iterative method, Gauss-Jacobi method of iteration, Gauss-Seidel method of iteration, and some problems relating to both the methods. First, starting with the iterative method. So we'll have a system of equations here. So here the system of equation must possess large coefficients R which are along the leading diagonal of the coefficient matrix. If only then this condition is satisfied, then you can proceed for an iterative method. So this condition is not necessary, but it is a sufficient condition. So when you have a system of equation, so you have to rewrite it in a matrix form. Then you have to check whether the leading diagonals are larger coefficient other than the other elements, and then you have to proceed with the method. So here we have a11 x1, a12 x2, a13 x3 which is equal to b1. So we have system of equation, three system of equations with three unknowns, and the leading diagonals here are a11, a12, a22, a33, and the method is solvable only if the modulus value of the leading diagonal must be greater than the sum of the other two modulus values in that equation. So here in the first equation the leading diagonal value is a11. So the modulus value must be greater than the other two values, that is a11 plus a13. Okay, likewise you have to check for all the three conditions. So we'll go for the first method, that is Gauss-Jacobi method or Jacobi method of iteration. So here you will have a system of equations. As we have discussed earlier, you have to check whether this method can be solved using the iteration method. So you have to check whether the leading diagonals are dominant or not. So this condition is very important. If you skip this condition and if you go for the problem, the total problem will be wrong. You have to check the leading diagonals are dominant or not. After checking, if it is dominant, you can proceed with the Jacobi method of iteration. So after checking the first equation, you have to keep only the x variable in the left hand side and take all other terms to the right hand side. So it will become x is equal to 1 by a1 into d1 minus b1y minus c1z. Likewise, for the second equation, y is equal to 1 by b1 into d2 minus a2x minus c2z. And the third equation, keep the z term on the left hand side and take all other terms to the other side. So z is equal to 1 by c2 into d3 minus a3 x minus b3 y. So this is your order of x, y and z. You must not change the order. So after checking the dominant, the same order should be maintained throughout all the iteration. Now starting with the iteration. So the first iteration, the initial values will be x, y, z, x, y and z will have your initial values as 0, and you have to substitute the values of x, y and z to be 0 in all the equations simultaneously, so that you get the values of x, y and z. When the values which you get in your first iteration should be substituted for your second iteration, and the values which you get for the second iteration must be substituted in your third iteration. So this process continues until the convergence is assured. So until and otherwise you get the consecutive iterations for the three iterations the same value, till that you have to continue the iteration. So maximum for a sum it will go up to 9 to 11 iterations. So we'll see an example sum. So solve the following system of equations by Gauss-Jacobi method. So the given system of equation is 10x minus 5y minus 2z is equal to 3, 4x minus 10y plus 3z is equal to minus 3, x plus 6y plus 10z is equal to minus 3. Now rewrite the given equation in a matrix form, that is, write all the coefficients of the x, y and z in one matrix, that is 10 minus 5 minus 2 4 minus 10 minus 3 1 6 10. Now we have to check whether the leading diagonals are dominant or not. Since it is the sufficient condition for a iterative method, the first step is to check whether the leading diagonals are dominant or not. So checking that the modulus first row, the leading diagonal value is 10, which is greater than 5 plus 2. Okay, and checking for the second row, the leading diagonal is minus 10. Take only the modulus value which is greater than 4 plus minus 3. And the last row, the leading diagonal value is 10, which is greater than 1 plus 6. So all the leading diagonal elements are dominant. So hence we can start with the iterative process. Now for the first equation, keep the x value in the left hand side, take all other terms to the right hand side. So the equation becomes x is equal to 1 by 10 into 3 plus 5y plus 2z, and in the second equation keep the y term on the left hand side and take all other term to the right hand side. So y is equal to 1 by 10 into 3 plus 4x plus 3z. Next, z is equal to 1 by 10 into minus 3 minus 6 minus 6y. So this is your three equations. Now starting with the iteration, have your first iteration. Here the initial values are x is equal to 0, y is equal to 0 and z is equal to 0. Substitute in the equation 1. So you can substitute all the values simultaneously. After substituting, you get the x values as 0.3, y value as 0.3 and z value as minus 0.3. So next, proceeding for the next iteration, keeping this values, that is your values which you got in your first iteration as your initial values, and you have to proceed with the second iteration. So in second iteration, the values of x you have to substitute it as x is equal to 0.3, y is equal to 0.3, z is equal to minus 0.3. So after substituting that, you get the x values as 0.39, y value as 0.33, z value as minus 0.51. Likewise, you have to proceed until the convergence are obtained. That is, for successive 3 iteration, you must get the same values. For all the x, y and z, all the 3 unknowns also, you must get the same value for the 3 consecutive iteration. So we have to proceed like that. So third iteration, fourth, fifth, sixth, seventh, eighth, ninth. So here if you see, for the seventh iteration, the value we got here is 0.341, y value is 0.285, z value is minus 0.504. For the eighth iteration, we got the same value. For the ninth iteration also, we got the same value for x, y and z. So we can stop with the ninth iteration. So when you tabulate all the values here for the first iteration and second, third, fourth, fifth, sixth, seventh, eighth and ninth, the last 3 iterations are similar values. So you can consider the digits after up to 3 places after the decimal points. So here you have 0.341, 0.341, 0.341. So all the 3 iterations we have got the same value. So we can stop with this. So the value for x is 0.341. The value for y is 0.285. The value for z is minus 0.505. So the next method is Gauss-Seidel method of iteration. The same method. It is slightly similar to the Gauss-Jacobi method, but there is only one change here. You'll see what is it. So the Gauss-Seidel method is, we have to start as like the Gauss-Jacobi method. That is, we have to check whether the diagonal elements are dominant or not. So that is your main condition for iterative method. So after checking the diagonals are dominant or not, we have to rewrite the x, y and z in the same order. Up to this there is no change. It is same as such the Gauss-Jacobi method. After that, in the first iteration, here in Gauss-Seidel method, only the y and z value we will have it as 0. So kindly note it. So here in Gauss-Seidel method, only the y and z values will have 0. Okay. So we have to substitute y and z as 0 in x equation alone. Okay. So here you have to note this mainly. Here you have to consider only the y and z values as 0, and you have to substitute that in the x equation, and you have to get the value of x. And in the y equation you have to substitute the x value which you have got here, okay, and the z value as 0. When you come for the z equation, you have to substitute the x and y value which you have got in the first iteration itself. You have to substitute in the z value. Likewise, when you go for the second iteration, you have to take the values of y and z alone from the x, that is y and x values from the first iteration, and substitute in the second iteration x equation, and you have to get the value of x, and you have to substitute in the y equation with z, same z value, and you have to substitute the x and y values which you have got in the second iteration in the same z equation. So this is the only difference between Gauss-Jacobi method and a Gauss-Seidel method. So here also the procedure has to be continued till the convergence is assured. So we will see an example so that it will be more clear. So we will see a note. For all the system of equation, this method will not work. It converges for only special system of equation. So as we have seen already, only for a certain system of equation, this iterative method is applicable, because all the system of equation we cannot say that the diagonal elements can be dominant. And the iterative method is self-correcting method, that is any error made in computation is corrected in the subsequent iteration. Yes. So the previous the mistake which we have done in the previous iteration can be corrected in the next iteration itself. So the last point, the iteration is stopped when the values of x, y, z start repeating with required degree of accuracy. So all these are some of the nodes of Gauss-Seidel method of iteration. Now we will see an example. So we have a system of equations here, 8x minus 3y plus 2z is equal to 20, 4x plus 11y minus z is equal to 33, 6x plus 3y plus 12z is equal to 35. Now consider only the coefficient matrix. 8 minus 3, 2, 4, 11 minus 1, 6, 3 and 12. Now we have to check whether the diagonal elements are dominant or not. So in the first row the diagonal element is 8. So it is greater than the other sum of the other two elements. Okay. The next row, the dominant, that is the diagonal element is 11. So 11 is greater than the sum of the other two elements, that is 4 and 1. And in the last row, the diagonal element is 12, which is greater than the other two elements. Okay. So we have all the diagonal elements are dominant. So we can start with the iterative process. Now rewrite the first equation. So keep the x value in one side and take all other terms to the other side, and keep the y value in the second equation, y term, in the left hand side and take all other terms to the right hand side. Likewise, in the third equation, keep the z term in one side and take all other terms to the other side. Here also you must be very careful. You must not change the order. Here you have to take only the x term in the first equation only. You cannot change the order. Okay. Now in the first iteration, only the y and z values must be the initial value 0. So substitute those values in the first equation, that is your x equation, and get the value of x. Now in the y equation, you have to substitute the x value which you have got here and the z value as 0 itself. And in the z equation, you have to substitute the x and y value which you have got in the first iteration itself. So you got so we have got here the x values as 2.5 and y value as 2.09, z value as 1.143939. Now going for the second iteration. So you have to take only the y and z value from the first iteration, substitute in the x equation. So you get a value, and for the y equation you have to substitute the x value which you have got here and z value from the first iteration, and for the z iteration you have to substitute the x and y values which you have got in the second iteration itself. Same, likewise you have to proceed until the convergence is obtained. So the third iteration, fourth iteration, fifth iteration, sixth iteration and the seventh iteration. Okay, now we can check whether all the values are similar. So here we have x value 3.016606 in the fifth iteration. In the sixth iteration we have 3.016767, and in the seventh iteration also we have the similar values for x. Likewise, when you check for the y and z value, in that also we have similar values in all the three iterations. So with this we stop the iteration process. Yes, so we have tabulated all the values which we have got in all the iterations. So for the first iteration, second, third, fourth, fifth, sixth and seventh. So since the last three iterations we have got the similar values, so we have stopped with the iteration. So x is 3.0167, y is 1.9858, z is 0.9118. So compared to Gauss-Jacobi method, Gauss-Seidel method is little time, it will reduce your time because we can stop with some iterations itself. But Gauss-Jacobi method can take you to many iterations. Gauss-Seidel method can give you accurate answers compared to Gauss-Jacobi method. Thank you.